Okay, we are going to see close packing of spheres in one dimension. So there are three types or three steps by which we can able to understand the close packing. One is the one dimension, then two dimension and three dimension. One dimension means we are just packing the spheres of particles in a single line. That is the one dimensional package. By that we are getting a row or one corner of the crystal you will be getting, and the coordination number is going to be 2. That means the number of particles attached between two atoms are 2. So this is the simplest packing known as one dimension. Whereas in the case of two dimension, it can be arranged by two ways. That means in the one dimension only we are creating the two dimension. This will be square close packing or hexagonal close packing. So the two ways how it is. Square close packing means we are just arranging them in a square manner. That means one below the other one. This is the first one dimensional package. When we are keeping the second line, we are just keeping the second spheres just below of the first sphere. That way we are going to arrange. Just you see that first one two dimensional package. That means the particles are going to arrange just above the first one. Then again the third layer will be coming like that, like when we are standing in front of a assembly line and like that. So this way we are arranging. That is the square close packing in two dimensional. So the coordination number you see, that is 4, because the central atom or central particle is touched by 4 spheres, and when we are drawing the centers of that spheres we are getting a square. That is why this package we are calling as the square close packing. So if you are keeping above like that, if you are naming the first one as A, second one again becomes same as A, third one again becomes same as A. So that is why this is known as the A type of arrangement or square packing. So this is the one way. Second way, in the two dimension we can see we are keeping the second layer in between the space of first layer in a staggered manner. You can see that the second spheres are keeping just in between the space of the first sphere. So that way we are utilizing maximum space between the particle. And if you are naming the first layer as A, then second layer is totally different from first layer, that we can be named as B. Then again if you are keeping the third layer, you can see that that is coming similar to the first layer, which will be named as A again. So this type of package we are calling as the AB package. And see the coordination number, central particle is attached by 6 spheres, so the coordination number is 6. And when we are drawing the centers of these 6 spheres, we are getting a hexagon. That is why this package we are calling as the hexagonal close packing. This way we can arrange AB type of package. This is what we are calling as the hexagonal close packing in two dimension, and this is the most economic or efficient manner compared to the previous AAA type package. So these are the two things we are just now discussed. First one is square close packing, and second one is the hexagonal close packing. So in hexagonal close packing, maximum space are occupied. That is why it is highly efficient. So here you see, this is the space what we are calling as the void. The space between the particles we are calling as the void. So void is maximum in square close packing or minimum in hexagonal close packing. So this way hexagonal close packing is the most economic or most efficient one compared to square close packing. So actually we have to study the three-dimensional package from both cases, but we are going to study in detailed manner from the hexagonal close packing. So what do you mean by this three-dimensional package? Three-dimensional package means we have to keep again the third layer above the second layer. So first we made first layer, then second layer, like that we are going to build up. So in the three-dimensional close packing, we are just going to see both cases. That means in a square close packing also, and also in the hexagonal close packing. So from two-dimensional square close packing, if you are preparing a three-dimensional close package, all the layers will be standing one above the another. So this is the first layer of two-dimensional square, then second layer will be coming like that. Above that, exactly above that, third layer will come like that. It is repeating n times to make a three-dimensional package. So see, the space is not occupied that much, or efficiency is very much less compared to our next method of hexagonal close packing. But still, this is one of the way of three-dimensional close packing in square close packed structure. So each one is contacted with 6 spheres. So its coordination number becomes 6 here. By counting the upper layer and lower layer contact, we are getting 6 spheres contact. So their coordination number become 6. That is coming under the three-dimensional close packing from square close packed structure. See how it is coming. If you are labeling A in every layer become A only, means every layer is similar to the first layer. So this package we are calling as the AAA type package, similar to two-dimensional square close packed structure. So these are the points you have to remember for the simple cubic lattice, and its unit cell is primitive cubic unit cell. Simple cubic also we can say, or primitive cubic unit cell also we can say. So next thing we are going to see from a hexagonal close packing how we can make the three-dimensional arrangement. So for making a three-dimensional arrangement, we are having two methods in the hexagonal close packing. That means, hexagonal close packing means we are keeping the second layer above the first layer in a, what we can say, space between each other. So when we are keeping the second layer above the first layer, there are two voids or two spaces they are creating, depends upon the shape of the void or from how many number of particles that voids are going to make. These are the triangle shape are the voids of hexagonal close packing. So after keeping the first layer, when we are keeping the second layer, you can see that picture. You are having a two types of void. Just listen or just see that video, then you can understand that exactly. See, anyway, second layer is different from first layer, already we discussed. Okay, that is keeping above the first layer. So that is the AB type. So see that triangle voids are coming below of the first layer. When we are keeping second layer and first layer jointly, they are making a void that marked places. So I want to say two types of voids here. One is tetrahedron voids and second one is the octahedron voids. How it is forming, let us see. When we are keeping the second layer above the first layer, if the second layer is kept above the triangular void of first one, that four spheres jointly making a void, this is what you are seeing, tetrahedral void. That means from the first layer and second layer together at the center of the first layer sphere creates a void. That is what we are calling as the tetrahedral void, because that void is actually created at the center of the first layer sphere. Whereas in another case, first layer 3 spheres and second layer 3 spheres jointly created at the same place, they are having octahedron shape. That is why it is known as the octahedral void. So this is the second type of void when they are creating or when it is preparing the second layer above the first layer. So this way you are creating two types of void, tetrahedral void and octahedral void, depends upon how the shape of the voids it is forming. See that they are having a shape of octahedron. That is why this void we are calling as the octahedral void. So when we are going to find out the number of tetrahedral and octahedral void in a crystal structure, just we want to know the number of spheres in the crystal. Suppose you are having n number of particles in a crystal or n spheres in a crystal, then you are having n number of octahedron voids, whereas tetrahedral voids will be 2 times of that n number. That is, number of tetrahedral voids will be 2n. So by knowing this concept, we can able to find out the number of particles in a unit cell and also the formula of the unit cell. Now we are coming back to the three-dimensional package. When we are keeping a third layer over the second layer, there are two ways by which we can able to keep. Whether we can keep above the tetrahedral void or we can keep above the octahedral void. Depends upon that. We are getting two types of package. That is, we are calling as the CCP package or HCP package. So uh, let us see that how it is coming. If it is coming in the tetrahedral void, what will happen? Let us see. So I told you tetrahedral voids are coming just above the sphere of the first layer. If you are keeping the third layer above this tetrahedral void, if you are keeping above the tetrahedral void, that third layer will be exactly similar to first layer. If you are naming the first layer as A and second layer as B, then third layer again becomes similar to A. That is why this package we are calling as the AB package, or this is also called as the hexagonal close packing, HCP, or hexagonal close packing. So remember, in the hexagonal close packing, the third layer is kept above the tetrahedral void of the second layer. Tetrahedral void is formed by the second layer 3 spheres and first layer 1 sphere. Here, each sphere is in contact with 12 other spheres, so its coordination number is 12. 6 in the same side, 3 above and 3 below. So these are the coordination number of HCP pattern. When the spheres are keeping above the octahedral void, see, octahedral void means that is similar void of second layer and first layer. So if you are keeping the third sphere above the octahedral void, that is totally different from first and second layers. So if you are naming the first layer as A and second layer as B, then the third layer will be similar to first layer. Sorry, third layer is totally different from first layer or second layer. So that will be named as C. So the pattern will be ABC pattern, or this is also known as CCP pattern or cubic close pack of three-dimensional package. So this is the way of another arrangement in three-dimensional in an which word octahedral void. Okay, this is also known as ABC pattern, or it is also known as cubic close pack structure, or CCP pattern, or simply we can call this as face centered cubic pattern. Thank you.